Hello and welcome to Eyes on the Prize. We're going to talk about simple and effective dashboard visualization techniques today. My name is Kevin Fiesel. I run a predictive analytics team out of Durham, North Carolina. I'm also a Microsoft Data Platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is that I'd like to try to find and link to 5 to 10 interesting posts per day on topics like database administration or development, R, Python, Kafka, Scala, Spark, Hadoop, Power BI reporting services, security, or the entire broad data platform space. That's curatedsql.com. What I want to talk about today is dashboards. So naturally, the first place we need to talk about is, what is a dashboard? Well, a dashboard will tell us about some critical business or operational metrics. The biggest thing that I think makes a dashboard is that it's a single pane of glass. A report can span page after page after page, but a dashboard is something you want up on a screen to look at and to gain insights. Part of the tricks to gaining insights is you put like things together. So your key performance indicators, bunch them together logically so that I look in one place to see them. Ultimately, I love this quotation from Stephen Few. Dashboards are not an appropriate venue for artistic impression. This is not where you build your creative masterpiece. This is where you get relevant business information in front of the eyes of the people who need to see it in the most efficient manner. There are 3 types of dashboards that we're going to talk about today. The first type is operational dashboards. These are going to provide day-to-day information that will assist your line employees in making decisions. That means that they tend to be very specific to the user base. So here I have an example of an actual API chart that my team uses. We have some APIs to monitor, and what we want to do is check out how frequently people are hitting our APIs. We want to figure out what the response time is. If we see a spike in response time, then we may have a problem. So that means perhaps we go investigate it. We may have measures for what the 95th percentile needs to be versus what it is right now, and if it's too high, we can investigate. Operational dashboards are going to drive action. This is a picture of a control chart. So it's a specific type of chart that is used in technical fields, especially in things like manufacturing, where I need to bore a hole that is exactly this many millimeters wide. And if we are outside that range by a certain amount, we're okay, we're within tolerance. But if you go past that level of tolerance, your system may be out of control. And if you're going out of control, we may have to stop the line, we may have to fix the machinery, at least figure out what's going on. So this type of chart shows us how far off from perfect we are, and as we move away from perfect, then it alerts operators and they're able to take appropriate remedial action. Strategic dashboards, meanwhile, are going to focus on some key performance indicators. So we're going to track this data at generally an aggregated level. It's not necessarily near real time. It's not going to be focused in measures like that API chart. Instead, this is an example of a pretty decent strategic dashboard that I found on the internet. It's not perfect. I can have my quibbles with it, but at least it tells us a relevant story about revenue, customers, and acquisition costs. A tactical dashboard fits in between these two. It sort of straddles the line. There is debate in the field about whether tactical dashboards really exist or if they're just a different twist on operational or strategic. I tend to think that they do exist. I like to think of them as they're showing you strategic data at more of an operational level. This is for people who really want to dig into the numbers. The strategic dashboard is very high level. It's intended to show you those top level measures that maybe are important for your C-level types. The operational dashboard is for your line employees. It's to show you what's going on right now on the line. The tactical dashboard is the in-between space. maybe a VP level, maybe a higher level manager type, even your CFO, or even down to the accountants, they want to take those strategic measures but drill into them a lot further than what you would normally get on a strategic dashboard. And that's where the tactical dashboard fits in. Let's talk about what makes for a normal dashboard. And I put scare quotes around normal for a reason. This is a dashboard, found it somewhere on the internet. And if I were talking to you in person, I would ask, okay, tell me what you see with this dashboard that is troublesome. Tell me the problems that you see. And I think you're probably going to see several of these problems pop up. In any classroom where I give this talk, I have people shout out answers. And you can shout them out right now. I'm not going to be able to hear them, but go ahead and shout them anyhow. And I'll tell you, yep, you're probably right. So a normal dashboard, we can see that this is not good. Intuitively, we have this understanding. That's not really a great dashboard. But you may not be able to articulate all of the reasons why. So what we're going to do in this session is arm you with knowledge so that we can go back to that dashboard and understand exactly why it is trouble. Speaking of knowledge, let's talk about it. So our key, the thing that I want to get you out of this is a great dashboard will evoke one of two emotions, happiness or anger. If I look at this chart and I get angry because something is messed up, I need to go fix this right now, then as a dashboard writer, I've succeeded. So if those line employees are angry when they see that, or if they're happy when they see, yep, we're still in control, everything's fine, that's the emotional response that you want to get. If I show this to a manager like 4 levels up, they may look at this and be befuddled. I don't understand what this means. I mean, what do those numbers actually represent? I see red dots. Is that important? That kind of emotional lack of response is the death of a dashboard. If I look at the dashboard and get nothing out of it, I'm not going to keep looking at it for very long. And this is, I think, what happens with a lot of dashboards. You splay a bunch of numbers on the screen. People look at it once and say, I don't really know how to make heads or tails of this, and they stop looking at it. So we want to evoke that emotional response, one of those primal responses, happiness or anger. How do we do that? Well, you have to figure out who is your audience and how are they going to use this thing. So this will help us answer the questions of how do you want them to respond when they see something? Our intended audience definitely matters. If we're dealing with line operators, I'm going to show you very specific things. API response time over time, or a number of millimeters of difference from perfection. Lower level management probably is fine seeing those same details, but as you start getting higher and higher up the chain, they care about different things. This is where we pivot from those operational requirements to strategic requirements. The board does not care how many millimeters of tolerance your system has because you have people to fix that stuff. They don't have time to fix that stuff. They don't have time to care about it. Just like how the person on the line doesn't really have time to care about filling sales quota for the next quarter. Different groups of people have different solutions that they're offering, and how you're going to give them the data they need to make good plans, it matters a lot. So this operational dashboard, again, works great for my team. My team members can see it. They can look at it. They can see, okay, well, things are looking okay right now. I, as the manager, can look at it and say, yeah, okay, things look okay right now. I can show it to my boss, and he understands what an API dashboard is. He may look at it and say, oh, that's cool, okay. His boss, again, knows what it is, but doesn't really need to care about whether our APIs are doing well or not, except in as much as they're going to affect revenue or customer retention. Similarly, go to his boss, the chief operating officer. She's not going to care at all about this stuff, except to the extent that it affects strategic measures like customer churn. So she is not going to look at this dashboard. We don't want her looking at this dashboard. It's just a waste of time for her. We want to show her measures of, well, if we don't hit these KPIs, then here's what it does to customer churn. At that point, then the message can come down and my team can figure out ways to put markers in. Okay, well, we need to hit this level. So it's a process, but this kind of dashboard really is intended for line employees who have a deeper understanding of the systems themselves. So how are people going to take advantage of this? You've made them angry or you've made them happy. Well, how are they going to do something about it? And your job is not necessarily to tell them what to do. It's to get them the information so that they can see what to do. If on the prior dashboard we see one of the API endpoints spike in terms of response time, then that could make me angry. I'm angry. I want to go see why it's spiking. And now I can investigate that particular API endpoint rather than being lost and just assuming that because customers aren't complaining directly that everything's just fine. So a couple of considerations when you're building out a dashboard. Do customers need to see historical data? Sometimes they do. And if they do, the types of visuals you create will be quite different from if you just need to see the present value. So if I just need to know that our API response time is 28 milliseconds and our goal is to make 50 milliseconds, I may not need to see what it was in the past. It might be useful, it might not be useful. And that's a consideration that your end users are going to help you make. And then, can you help them act? So if I see that this API has spiked, what can a user end up doing? How can those line employees act on it? Or if we see quarterly revenue fall or year-over-year revenue fall, how can those business higher-ups act? So can we display certain rules that, well, if you've dropped more than X%, then you want to take some action? If so, building that into the dashboard is helpful because it takes away some of the need to think about how we can operate on this. I see the red button that says, hey, we've got to stop the line because tolerances, we've exceeded tolerances so many times in the last hour. Bam, that dashboard has just told me I need to act. So I can act and not have to think about, well, let's see, if it's been 7 times, then let me go look up in the rule book what that means. The other thing I'd like you to keep in mind is how your audience will view your data. There's a huge difference between a, say, power user who's got a 40-inch 4K monitor and they can take your dashboard and bring it down into some tiny amount so you can pack the screen with huge amounts of data. And maybe they're used to spending all day in Excel building out charts at like 70% magnification. That is okay. You can pack a huge amount of data on there. But if you try to take that dashboard and send it to the CEO who is looking at it on a phone between meetings, that's not going to work out very well. So figure out how people will behave. If you're using a phone, buttons have to be very big. It has to be easy to press, hard to miss. You can only include a few visuals on here, therefore. A tablet, you get a couple more, but again, buttons are big, hard to miss, easy to press. If you're on a desktop, then things can get a little finer, and you expect that somebody's got a mouse, so you possibly have the option of a smaller button that you can click on to take you to a report or to a website. But what if they're viewing this on a TV? Maybe it's something like whether the build is broken. Here are your builds. Let's see which ones are broken. Let's see when they last built. That's on a TV. You don't expect the person to have a mouse and keyboard or a touch screen. So you have to show all of the information on the screen without them acting. How your media is intended to be used will affect how you should design your dashboard. You also want to make sure that you've got the right measures. if you're talking about a sales team, we want sales-centric measures. Yes, I can make an argument that API response time over time has a downstream effect on salespeople. If my APIs are too slow, customers stop using it. If they stop using them, they stop buying our product, and therefore salespeople need to know what they are. In practice, they don't really need to know. They care about things like the sales pipeline. Are people going to make their quotas? How is the company looking over the next 6 or 9 months? So if I include server uptime or a number of high severity issues or API response time over time, it is irrelevant in an en passant way, but not something you want to put on a dashboard where you have a limited amount of space. So a very simplistic mock-up. Now, this is just a quick mock-up in Excel. You could make it look a lot fancier, but all we have are the steps in the process. So think of this as a funnel. You have a certain number of people contacted, and you figure out their potential revenue, and then the probability that you're going to snag these customers gives you expectations of revenue. So you see that for each step in the pipeline, and you can aggregate this for expected pipeline value and Q3 results. So here, even though this is incredibly simplistic, it's not pretty, but it does give a sales manager the ability to see what's going on, what's in the pipeline, what we're expecting to get from Q3, and therefore be able to report to finance, hey, here's our expectations of sales, so you can build that into your projections and release that to the public if you're a public corporation. Now we can touch this up, we can make it look prettier for sure, we could add a bit more to it, but at its core, this is the information. And as a sales manager sees those numbers change, with some experience, that person can know those Q3 results are a third of what they should be. I'm now very angry. What is going on? Why are these results different from my expectations? Cultural differences can also matter. So the color, for example, can have a huge difference depending on who's viewing your report. For example, most European cultures, American, Canadian culture, red typically means either love or danger. Sometimes both, depending on who you marry. In finance, red is a negative value. It's scary. It's dangerous. We're losing money. By contrast, in China, red has historically meant prosperity. So people give gifts of money in little red envelopes. You give those at weddings. You give them during major holidays. You give them among each other. Little red envelopes, it's a sign of wealth. It's a sign of success. Yet, interestingly, their accounting systems also use red as negative. So, but that color you choose can mean a lot depending on who your intended audience is. Let's take a little bit and talk about visual principles. So in this section, I'm going to show off 6 important visual principles. The first one of these is cognitive load. There is a study that was done. Now, with a lot of these, what happens is you take some undergraduate students who have to attend a psychology course, you pay them $5, and you make them do some silly survey. And then from that, the professor gets to write a paper about it. So cognitive load, a bunch of undergraduates were studied. How many numbers can you hold in your head at a time? And the end result was somewhere around 3 to 7. So take some of this with a grain of salt. It is not necessarily absolutely true for all people at all times everywhere. Nonetheless, let's work with it as a rough concept. So working memory holds a certain amount of information. You can think of them as registers, and then long-term memory is more like RAM. We take information and we move it out of our registers into RAM as we decide that we need to keep it long-term. Sometimes that just gets dropped out of registers, doesn't go to RAM, and it's gone. Well, what does this mean for us? What it means is that we as dashboard designers want to look for ways to reduce that mental load. Try to keep people from wasting those precious registers looking at things that are unnecessary. Also, allow people to bundle things together mentally so that is one thing instead of four things. Then you can have more on the screen, and yet it's not more cognitive load. It's not more complex for a person because you're able to compartmentalize it appropriately. Some of the ways that we do this, we can group things together, similar size, shape, similar color, thickness. This is coming from a German school of psychology called Gestalt, or form. And the concept is that we are really good at considering things that look alike to be the same. So if I have 8 people in green shirts in front of me, they're all wearing the same shirt, same color shirt. My first assumption is, that must be a group of people who are together, because typically you don't see a bunch of people wearing the same green shirt. Maybe they're going to a ball game together or something, or they're part of some group that's going to go out to do whatever. So we see them and mentally associate them together. As a person who's designing dashboards, you want to take advantage of that. If revenue is there, you can have revenue be the same color every time. All the revenue measures, similar colors. That way, people look at this, see this color, and say, that's revenue. We can also remove noise from the reader. So get rid of things that cause unnecessary load. If it doesn't help tell your story, it's better to get rid of it. All that stuff has a technical term. It's called chart junk. It's the stuff that does not help the reader understand what is going on with your data. So let's look through an example. I created something that is hideous. And on this dashboard, I've got quite a few problems with this. So first, top left, have our company logo and sample dashboard. I like getting rid of those because I like to joke that you know what company you work for, so you don't need to splash your company's logo on the dashboard just to remind people that they still work at your company. So we could get rid of that and save some space. The title sample dashboard can stay. It's informative enough. It tells people where you're at, what dashboard you're on. On the left-hand side, we have entries by year as a donut chart. I hate donut charts. I'll get into why later. But my real problem right now with this chart, one of the problems I have with it, we look at the year. The year is in a legend. So we see 2015 is a teal, 2016 is this gray to black, 2017 is a red. And we start looking, and especially if there's more than 2 or 3 elements in the legend, you kind of forget, wait, what was that grayish black again? What year was that? And you have to look up and down. Your eyes are scanning up and down as you go back and forth between the legend and the image. The more of that eye bounce that you see, the worse your dashboard is. You want to keep people from bouncing their eyes back and forth just to understand what's going on. They should be able to see and understand. Then, to the right of it, we have a tree map. Tree maps we'll talk about in a little bit. Below the 2 visuals, we have text. Maybe this is the first time you've seen this dashboard, so we're going to put on a bunch of text that explains what is a tree map or what is a donut chart, what is the information that you're seeing on here, and so on. This is potentially helpful for somebody who has never seen it. As soon as a person has seen it, it's just a waste. It's extra text that is completely unnecessary. Those people aren't going to look at it again. So you've wasted space that you could be using for something better. You could hide that off as help, either in some documentation or maybe like a mouse over tooltip for people who, if you do have the expectation that you're going to use this on a desktop. Lastly, I have arrows because I actually want to tell people, go look at the tree map first. But I've got so much junk on here that people are not going to look at the tree map first. So I use the arrows to point them in the direction. That's just a sign that things are really bad. So we get rid of a lot of the clutter. And what we have left is title, the donut chart, and the tree map. Well, from here, as I mentioned, that legend is kind of ugly. If I remove the legend and I just have the labels next to the values, now at least you're not bouncing your eyes back and forth. Donut charts are still bad, but this I think is better than a donut chart with a legend. If you have a detailed legend with a lot of different values, you might be using the wrong visual. You might want to use a different type of visual, one that doesn't have to have a legend. Next, let's talk colors. So I recommend reducing color usage. Here I have a chart, and this is just a simple bar chart of entries by state and country. And you may ask, well, how are Kentucky and Ohio related? They have the same color. Color is one of those things that we look at, and mentally we assume that if two things look the same, they are the same, or at least they are similar. So while we start trying to come up with ways how those two states are similar, oh, they are neighboring states, it turns out that no, this is just Power BI's default for color scheme. What we could do instead of having a different color for each state, have one color. We've lost zero information. It's clear that these colors were not helping us do anything. Furthermore, I can then tell you there's one state that we really need to talk about right now. And I don't even need to name the state, but you have already seen what it is, because I've been able to use color as a pre-attentive attribute, and B, sort of an associational attribute. So pre-attentive means it happens before you even think about it. You noticed that color difference before even thinking about, oh, there's a color difference here. It just came to the back of your mind, and so it immediately jumped out. Well, I also use it for association, that look, this state is not like the others, and we're going to talk about why. Color can also, as I mentioned here, be associative. So here's another example of association. I have two pie charts. In both pie charts, I'm using the same colors, and therefore, if you don't look at the legends, and frankly, a lot of people don't look at legends, same color, they assume that, oh, well, the percentages are basically the same. And if you do look at the legend, you find out that I've done something really bad on you. I flipped the legend values. So in the first pie chart, blue represents yes. In the second pie chart, blue represents no. So it's actually the inverse. This is confusing. It may be confusing on purpose, and that's deceptive. It may be confusing on accident, and that's just bad design. Either way, it's not something we want to do. Try to keep color with a meaning. So if you use yes and no, and you do have colors, keep yes the same color consistently. Keep no the same color consistently. Also, I recommend not using 3D at all for most business charts. There are some technical charts, topological charts and mathematics. There are some physics charts where 3D is not only useful, but it's critical. For business charts like this column chart, 3D offers nothing. Furthermore, 3D adds pain because in Excel, it is really hard to figure out what the actual value of A is. We know that it's probably somewhere between 0.3 and 0.35, but you have to understand the way that Excel works in order to understand what that value is. And you have to think of it as you have a camera, and the camera is taking the view of that chart in 3D, and in order to see what the actual value is, you have to extend the plane of the bar back to the lines. That's a lot of work for a human to do for absolutely no gain. This provides zero benefit, and it adds a cost of making it harder to read what is the value of A. And by the way, is A bigger than or smaller than C? A little hard to tell. Let's now talk about languages. In European languages, typically we read left to right, top to bottom. In Middle Eastern languages, like Hebrew and Arabic, we read right to left, top to bottom. In ancient Asian languages, especially ancient Chinese, top to bottom, right to left. Modern Asian languages, Typically, modern Chinese, left to right, top to bottom. Modern Japanese, left to right, top to bottom, except when you go right to left, top to bottom, except when you go top to bottom, right to left. Japanese is one of those interesting languages where there's a lot more interplay in the way that you read. It's not something that I'm very good with. I certainly won't pretend to know Japanese, and I actually don't really know the rules very well at all. Just interesting to see how you will see differences in how you read based off of, say, your medium, or how you even want to lay out an advertisement. Like that advertisement on the right-hand side, where you have right to left, left to right, top to bottom, right to left, and I think there's even a section where it was top to bottom, left to right. So you see all of them on the same advertisement. It's kind of cool. But anyhow, assuming a European language, left to right, top to bottom, there's been quite a bit of research on how people will parse documents. And again, a little bit of a grain of salt, because much of this was done with college students in a psychology class getting paid $5 or $10 to do something. So keep that in mind. Gutenberg layout, first layout that we see. What we get out of this is that there's an area in the top left where people are mainly focused. We start reading in the top left because we read left to right, top to bottom. And in the top right, it's called the strong fallow area. Basically, people will start reading left to right, left to right, left to right. The bottom left, as you read along, if you're not interested, you're going to start missing stuff in that section. But you will read stuff in the bottom right because, hey, we're getting close to the conclusion, so maybe there's something important here. That was the first layout. The second layout, after more research, is a Z layout, a little similar to Gutenberg. So we still start in the top left because people read left to right, top to bottom. So left to right, and you kind of just scan through the middle, see if there's something that catches your eye. If not, you go down to the bottom and you read left to right. So here, the place where you can hide information is kind of between the 1 and 3. So you're further down in the middle section, or between the 2 and 4. That middle section on the edges, you can kind of hide stuff because people will just glance through it. Versus the F layout, where this one was done using people reading Washington Post articles. So this was a Jacob Nielsen survey. People start reading left to right, and they're pretty diligent about reading the whole thing, but then they start getting bored, and instead of reading the whole line, they just kind of skim and give up maybe 80-90% of the way through, move to the next line, and you get more and more bored, so it starts looking like an F. It starts coming backwards, where you're reading less and less until at the bottom you're just kind of skimming straight down, looking for something interesting. What was really cool about this study is that anything that broke up the pattern reset a person. So this actually is why in newspapers you'll see interstitial advertising every few paragraphs, because you read, you see the interstitial ad, it kind of resets you. Now let me start reading again. And you go back and read the whole thing across for a little bit. So that's their way of trying to jar something in you to force you to read the whole thing. These are useful, but they are good for evenly distributed homogeneous data, like newspaper articles or documents of text. A lot of text. Well, your dashboard probably isn't a wall of text. If it is, your dashboard may not be fantastic. So for image-heavy dashboards, and we are generally visual-heavy dashboards, people are going to follow a different principle, this idea of focal points. So here I've got a picture that has a bokeh. I have something that is in focus. I don't even need to tell you what you should emphasize, what you should look at, because your brain does it already. You see the blur and you see the area of focus, and so you move to the area of focus. Well, that same concept happens on dashboards as well, we have focal points. So I can show you a dashboard, and most likely you started by looking at either the column chart on the top right or the tree map in the bottom, depending on whether you caught the multicolors of the tree map or the big picture of the column chart. Not many people start with the table on the left-hand side. They eventually move to it, and very few people start with the drop-down list of city and state. I mean, it's gray, it's kind of hidden, there's not much in the way of text, and there are more dynamic elements right next to it. So what we do is, on a dashboard, we tend to bounce from one focal point to the next. In fact, you may not even have noticed the drop-down until I mention it to you. The rule of thirds also applies to dashboards. So here's a quick explanation of the rule of thirds in case you've never seen it before. You have a photograph or a painting or any sort of visual element. What you do is you break up that visual into thirds, horizontally and vertically. Your subject ought to be somewhere near the intersection of horizontal thirds and vertical thirds. So in this case, our subject is this bottle, and our subject aligns with 2 of those 4 intersection points. So the reason we want to do this is that our eyes naturally want to look at around a third of the way through. Things in the middle, see, in portraits you usually put a person right in the middle, and if you put them smack dab in the middle, it's actually not that great. Your eyes want to be at about the thirds. So you have multiple people, and now one person's on the right third, one person's on the left third. Maybe you have somebody else, children in front. They hit those thirds. So in a group shot, you want to hit those 4 corners. Also, if you're doing landscape work, you may notice that in a lot of landscape photography, the horizon is going to be one of those thirds. So in this case, the horizon is the top third. And we see that mountain in the distance. We see the water coming up to the third. In big sky pictures, you're out in, say, one of the Dakotas or Montana, and where it's flat and there's just beautiful blue sky, you're probably going to have the bottom third be your horizon so that you get that picturesque blue sky with with white clouds, puffy clouds. That applies as well. That's something that is aesthetically pleasing because that's where our eyes want change to be. The strategic dashboard that I showed earlier sort of follows the rule of thirds. We can see that for revenue, that first column chart is right at the thirds mark. The column chart for average revenue for customer, right at the thirds mark. Now the other 2 are pushed a little bit over. And so if I were doing this chart myself, one of the things I might think about doing is taking those graphs and trying to make them at the thirds. So we want to hit each one of those 4 corners and then have our text data around it kind of flow to meet the needs of those visuals rather than basically clipping our dashboard into 4 quadrants and smacking text on the left, visual on the right. We may redesign things to align better with the visuals being on those intersections. Glanceability is another critical thing. And I love the irony that I put into this slide, where glanceability is all about the idea that you as a human can quickly look at something and get relevant information from it. Well, this is my least glanceable slide. And I kind of enjoy the irony there. But what do I mean by glanceability? Well, no scrolling. If you have to scroll, it's not glanceable. You have hidden information, not even on the screen. We want to group functions, group metrics by function. Have the revenue metrics be together, the cost metrics be together. Don't make a person look in the top left for one cost measure, bottom right for another, and then middle in for the third. We want to differentiate sections. Now you don't want big black lines separating them because your eyes look at the big black lines. Instead, we may use negative space, just white space or empty space between sections Just a little bit goes a long way. Make it a little wider than you would make a separator between two similar elements. And now your eyes naturally say, oh, well, there's a gap. This is different. This is new. We want consistent layouts. If I see the color blue means yes, I want to keep blue as yes across the board. If I see that I have this bar chart of people, if I see a similar bar chart of people, I should be able to make assumptions that it's maybe the same group of people or a similar group of people, or at least even if it's different people, we're doing something that's about the same. So you don't want to have a lot of different visuals that really represent the same story but tell it in 8 different ways. And you also don't want to have necessarily one visual that can become really easy to, it becomes ambiguous, where I have this one visual and I show it 3 different ways, but it means 3 totally different things, and yet I'm using the same set of colors, for example. Make it easy to read too. One thing that I don't like with Power BI by default is that the fonts, I think, are way too small. Keep your fonts large. You have a person who's reading it on a phone. That person is not necessarily going to want to pinch zoom. Make it large. Your numbers typically don't have to be exact numbers. Nobody cares on a dashboard that revenue was $38,967,406.14. Make that, whatever, 98.7 million or whatever it is. That way, that's close enough. For a report, yes, you want the exact numbers. For an accounting system where you're doing GL reporting, yeah, absolutely, exact numbers. For a dashboard where you're looking and trying to gain information, rounding is generally okay. Another thing I want to talk about is color vision deficiency. This affects about 8% of men and 1/2% of women. There are 3 key types of color vision deficiency: protanopia, deuteranopia, tritanopia. Protanopia is a lack of red cones. Protanomaly is weakened red cones. Deuteranopia, lack of green cones. Deuteranomaly, weakened green cones. So when people say that they're red-green colorblind, most typically, they have deuteranomaly. But they are one of these 4. Tritanomaly and tritanopia combined affect about 0.5% of women and very, very small percentage of men. So what happens when you have color vision deficiency? Well, this is a picture of the Badlands that I took with a drone. We can see here yellows and greens. We have reds. So you have this red stripe in the sandstone. If I tell you have protanopia, we run this through, and now that red disappears. It becomes a black, and it can be easy to lose that red in this image and just not even see the stripe. You may have residual linked memory from having seen it in the full color picture, but here, yeah, it's there. It's kind of a blackish color, but it's hard to tell. If you have deuteranopia, you'll notice everything tinted a little bit redder. We lose some of the greens. Again, that red is difficult to differentiate. If we have tritanopia, the red just shoots out, it is extremely apparent, but the greens fade away. They almost become blue. So we have 3 different reactions based on the same picture, depending on what sort of color vision deficiency you have. This is important in our visuals because if you use 2 colors that overlap, it can be impossible for someone to read. So if you may remember integration services. This is SQL Server Integration Services 2008. If you have full color vision, this is what it looks like, and it's really easy to tell which tasks failed, which tasks succeeded. Well, if you have tritanopia, it's still easy to tell. Green becomes a light blue, but otherwise you have success and failure. If you have protanopia, it becomes a lot more difficult. different tints of yellow. So maybe you can tell that one is a failure and one is success, but it's much harder for a person. Deuteranopia, same thing. Yeah, you may be able to tell, but it's a lot harder to differentiate. If you have a business chart that's showing two of your customers and one is red and one is green, and they both look exactly the same, your manager may have deuteranopia, or at least deuteranomaly, and might not understand the difference between these colors. And that may make your manager look like a fool if he goes up to the board and mentions, yeah, customer X. And they say, no, that's customer Y because it's red. Don't make your manager look like a fool. What we can do, we can use color-safe palettes. That's one way to do it. In the integration services case, what they did in 2012 was to make it so that nobody could tell when something failed because they removed all color and had a little tiny icon that showed failure, and that was it. That's also probably not the best solution. Use color-safe palettes, though. There are color vision deficiency safe sets of colors that will guarantee no matter what sort of color vision deficiency you have, including if you're monochromatic, meaning you can only see black, white, and gray scale, then these colors will still be safe. Use grayscale for images, especially if they're going to be printed out. There are also colors that if you print them in grayscale, even though they look different, even for a person with CVD, they will end up looking exactly the same if you print them on a grayscale printer. One recommendation here is to use color sparingly. You don't typically need color very much. If you do use color, use it to highlight a particular element. Then you can still use red. You could still use green. You don't use them both together, but you use it as a single bar highlighted or a single dot highlighted instead of using a bunch of different colors across the board. If you have doubts about whether or not your color scheme is color vision deficiency safe, take a screenshot of it and upload it to a website like Coblis. So I have a link here. I'll give you a link at the end as well. That will help simulate different forms of color vision deficiency. So you're going to be able to upload that photo, see what it looks like if you are tritanopic or protanopic, and make your changes as a result of that. You don't have to guess, in other words. You have services that will let you do it for you. Let's now talk about different types of visuals. To this point, we've focused a lot on principles, but let's see what we can slap onto a dashboard. And I have a chart here. I kind of like this chart. It's a choose your adventures type story where I can show you that based on what you want to do, here are the types of visuals that might be good for you. And it's a good thing to walk through if you're not very familiar with visual design. I don't always fully agree with all of this stuff, but I think for the most part it's okay. First thing I want to talk about, a table or a matrix. This is something that people don't tend to think about as visuals, but it is just as much a visual as any other. If users need to compare data directly, this is great. A table or a matrix, especially on an operational or tactical dashboard, yeah, go ahead and throw it on there. If a person has a 40-inch 4K screen and they want to see a table of values, if they can make more sense from the numbers than from visual, it's okay to throw it on there. Strategic dashboards typically should not have tables because with a strategic dashboard, glanceability tends to be more important than drilling in. Column charts are really good when you have a few categories, but several periods. So you have periodic data and a few categories. Here I've got 3 Marvel Netflix shows, Daredevil, Jessica Jones, and Punisher. This was season 1 of each of the shows, and this is the number of critic reviews by episode. So we can see a trend in those 3, where all of them go down after the beginning, but then some of them stay more stable than others. So I can tell a story about what's happening with critic reviews during this time frame. A bar chart, meanwhile, is really good when you have one period, but many categories. It's also good when labels are lengthy. One thing that I really dislike is when people put vertical labels, put vertical text. If you have vertical text on your column chart, somebody's going to try to rotate that phone, but then you rotate the phone and now it flips to landscape mode from portrait, and all of a sudden you still can't read it because now it's just still vertical. So then you tilt your head try to tilt it 90 degrees, but it's really hard to get a 90-degree tilt, by the way. So it's just difficult to read when you could, as a designer, rotate it 90 degrees yourself and make it so that people who read left to right, top to bottom, can read left to right, top to bottom. So here I have critic reviews by show. This is a lot easier to read as a bar chart than it is as a column chart. Recapping. Choose a bar chart if your category names are long, you have a lot of categories, or you only have one period. A column chart is more useful when you're viewing across a series of periods with relatively few categories, and if those category names are really short, then you can get away with a column chart as well. Regardless of which you choose, make sure that you start at the origin. Here's a case of a chart where you look at it and you say, oh, the first estimate was like a third of the second estimate. That's a huge difference, because a lot of people don't look at the numbers. They just look at the relative sizes of the bars. And that's kind of what a bar chart helps you do. You can take advantage of size differences and not have to focus on numbers. But then you look at the numbers and you find out, wait, that's not 3 times bigger. That's like 16% bigger. This is a really bad chart. All bar charts and all column charts should begin at the origin. If you don't want to begin at the origin, don't use a bar chart or a column chart. Use something else. Use, for example, a Cleveland dot plot. So these are named after Bill Cleveland. This is a minimalistic visual for comparing categories. So now I have all of these different shows, and instead of starting at 0, I can put dots in at their average rating. So you'll notice average rating 8 to 10, so I also have 7s in there. I don't need to go back to 0 because nobody's back near 0. So I can leave the area focus tight and get more information packed in while not confusing people, because nobody's going to compare the size of those dots. They're all the same size. Instead, we compare how far to the right a dot is, and that means that the axis doesn't have to be at 0. Incidentally, this is a custom visual in Power BI. There are 0 built-in dot plot capabilities for Power BI. There are 2 custom visuals. One of them didn't really work at all for me when I put this together originally. The other one is this one, where it cut off the label. So neither one of them was that great, but this one was okay. Radar charts are all right for showing a normalized comparison of measures across several categories. Radar charts are typically a type of chart you don't want to use much. Here, it is interesting. It is okay, I think, because we're showing between these 5 shows percentage of critic reviews and user reviews by show. So Daredevil had the most critic reviews and the most user reviews. Luke Cage had the second highest number of critic reviews, but the lowest number of user reviews. Jessica Jones, the exact opposite. Fewest critic reviews, second most user reviews. So it's interesting seeing the dynamics in here. And that's what a radar chart is useful for. It's showing dynamics across a few categories. Now, admittedly, like I said, radar charts typically not that smart. Where I got my love for them actually was playing a lot of Madden, NFL, and franchise mode, where they would show this radar chart of player talents. It also turns out that that was completely bogus, that the chart values were almost useless. Nevertheless, I spent so much time playing it, I liked the radar chart as a result. Line charts are really good for time series data. Stretching over many periods, typically non-cyclical data, and we're showing few categories. Now I could also use a column chart here especially in this case where I've got Daredevil and Punisher seasons 1. And what I'm showing is the rating per episode. And here, the column chart would work, but I really want to show the progression. And I could tell a story. In fact, here's the story. Daredevil starts out pretty well, but then episode 2 was the episode where it was just one cut of Daredevil in a long fight. That's the thing that made people interested in this show. They saw the one cut, which is quite unlike modern movies where it's like 3 cuts to throw a single punch. Then it picks up. It's a really interesting plot line until about episode 10, where the writers realize they have 4 episodes left to do about 2 episodes worth of material. So episodes 10, 11, and 12 drag a lot, and you see the ratings drop. But then episode 13, just fantastic ending to the first season. By contrast, The Punisher starts off a little slow, but it's a slow burn. It builds up, and by the end of it, episode 12 was, at the point where I filled out all of this, the single highest rated Marvel Netflix episode, period. So we can tell this story using this data. I mean, I have some other information that I am able to bring into it, but as I'm walking you through the data, you can see that and say, oh yeah, okay, this stuff makes sense. Now we can combine line charts and column charts. Sometimes this is risky, but it works well if you have 2 interrelated but distinct variables. Typically, we'll see this with, say, stock market prices and volumes. Here I have Punisher ratings and the number of people who voted on the episode. So I wanted to point out that highest rated episode, not only was it really highly rated, but it wasn't the 12 Punisher fans who stuck around for the full season who voted it as a 10. Instead, this was there were more votes on this episode than most others. So we have a lot of votes that's pushing it really high, that says it's more than just a couple of fanatical people who clicked the button. So I mentioned column charts and bar charts should start from the origin. Line charts don't need to start from the origin. But Cleveland and then McGill and McGill proposed in a paper that the average line slope should be about 45 degrees. That way, you know roughly what size to make a chart. If you drag a line chart out horizontally, it'll flatten out. If you push a line chart in vertically, it'll look like you're jumping up and down in huge amounts. So what they wanted to do was have a pattern where you had approximately the right size so that all line charts would have about the same informative content. This was one paper. It was their opinion. There haven't been many other discussions around what this should look like, but Power BI and Excel, as well as other visualization tools, will automatically do something similar to this. They're going to try to find what is an appropriate line length. If you're working in R, ggplot does not really do it. It just takes whatever space you have and fills the line accordingly. Scatter plots are really good for showing 2 variables over a small number of categories. So here we have a scatter plot of number of votes and number of critic reviews by episode of each of the 3 series in this shot. I can tell a story about this, but what we have is, you can see clustering. You see general behaviors. Punisher ratings were lower because that came out several months after Jessica Jones, so there were several more months for people. Similarly, Daredevil came out earlier than the other 2. This is already a little difficult to read because you have overlap. Bubble charts are great for showing relationships between 3 visuals. So here I had number of votes, number of critic reviews, number of user reviews. So user reviews measured the size of the bubble. Well, that's really hard to read. There's a cluster with Daredevil episodes where it's real difficult to tell. Even when I only have about 39 data points on here, it's really hard to tell where the points actually are because the bubbles get so big. Tree maps are also risky. They're useful if you show the relative share of a value for a medium to large number of hierarchical categorical values. I have cities and states, or cities, states, and countries. Cities, provinces, and countries. Cities, general regions, and countries, whatever. I have a fairly proper hierarchy that I can drill through and get information on. A tree map can work for that. One of the best places that I've seen tree maps work is in a tool that's called Windirstat, WINDIRSTAT. This will plot out your C drive or your D drive or a folder, and it will show which files are taking up the most space by showing them as a tree map of file size. So if you have one file that's taking up an enormous amount of space, you'll see it very quickly. If you have tens of thousands of files in a folder, you'll see that pretty quickly. It's a good way of visualizing space utilization and then letting you drill into what that means. So now that I've talked about some charts, some of which I like, some of which are risky but are still fine, let's talk about a few that I really don't like. I will talk about when they're useful, but they're less useful than I want them to be. The whipping boy for all visual people, pie charts. Its best use case, simple share, static total. Critic reviews by show. I still don't even like it then. See, here's why we hate pie charts. First, angle differences are really hard to discern. If you look at this chart and I ask you, which is bigger, A or C? Which is bigger, B or D? It's hard to tell because our eyes are not very good at comparing angles. Small percentages are really hard to tell apart. You may see a chart where you've got several people at 1%, 2%. I can't tell the difference between them, and they're all just crammed together, so you have all these lines coming out from it. It's just ugly. Pie charts also tend to require legends. And if you have a legend, you have your eyes bouncing up and down. That bounce up and down wastes time, wastes energy, causes people to leave. As an alternative, if you're comparing a large number of categories, use a tree map. It's not perfect, but it's better. If you have a few categories, A, B, C, and D, use a column chart. With this column chart, I can ask you which is bigger, A or C, B or D. You can give me an answer immediately. It's real easy to tell. A is bigger than C. B is bigger than D. If you have a two-number thing, just use the numbers. 58% voted for candidate A, 42% voted for candidate B. You don't need a pie chart to show that. Just show the number 58 and the number 42. That's just as informative, takes up less space, and you don't have the person trying to figure out what that number is. Because half the time with a pie chart, you still show the number anyhow. So instead, just show the number. Gauges can show you progress toward a target, or as percentage filled. But I'm not a huge fan of gauges, in Power BI at least, for a couple of reasons. One reason, if you don't have that goal, if you don't have that line there, like target of 50, I am at 34. Is 34 good or bad? I don't know. The funny thing is, I never chose 68. 68 just happens to be twice the current amount. With Power BI, by default, if you don't set a maximum, it takes the current amount as 50%, so it doubles that to make the rest, and that's what you get as a gauge. That's not useful to a person because 68 is not meaningful. Stacked area charts are pretty useful for showing relative and absolute differences over data. So few categories, relatively few periods, and you want to see those changes. The problem I have with stacked area charts is that I can tell you two things with certainty. First, what the total number of reviews is, because that's the top black line. Second, what the number of reviews for Daredevil is, because that's the red line. The rest of it is dependent on what the values are for everything else. So for example, I can tell you that the number of reviews had gone down between episode 5 through about episode 9 of each of the shows. But it's hard to tell, well, which of these shows actually caused that decline? Did all of them go down? Did they go down about equally? Did some go up and others down? I can't really tell based on the visual. So what we could do is show this just as a line chart. And that way what we can see is between 5 and 9, yeah, Daredevil took a dip in episode 5, Punisher between 6 and 7, and Jessica Jones between 7 and 8. So we saw these declines for different shows at different points in time, and it all adds up to a general decline. Well, that's information I really would not have gotten just from the stacked area chart. If you have a person who's using this from a desktop, then a ribbon chart can be valuable. This is, I think, very noisy. There's a lot of a mess in it. But each one of those solid spots is the actual episode. You can mouse over it and it shows you differences. So at least here it shows critic reviews for Jessica Jones were higher than were higher than Punisher in episode 1, but that had flipped by the time episode 2 hit. So if you have a lot of changes in rank, then ribbon charts can be useful for showing that. If you have mouse over capabilities, then a person can look at those and get more information. But if I'm looking at this from my phone, it's not that helpful. Let's wrap up by looking again at that normal dashboard and trying to, now that we have the pieces in mind, let's understand why it's not very good. So this is our normal dashboard once again. And now let's hit it a piece at a time. I'm going to criticize the pie charts. It's just who I am. I don't think these pie charts are helpful. We have quite a few charts where you can't even see the slivers. I can't even tell you what those percentages are for most of them. So that's just a really poorly designed chart. Then I have too many colors on here. It's really hard to tell what's going on. In fact, if you look at the pie charts, there are several colors where they're so similar, I'm not even sure I could define which one is which. So next, unnecessary 3D. The pie charts have this glossy 3D coating. The column charts have this like rounding of the edges that make it look quasi 3D. You don't need any of that stuff. You can take that away without losing any information. I think there's category overload. You're showing too many things on here. And the worst part is these categories, the names are so long that the legend cuts them off. So violation of requirement or procedure, maybe. Insufficient practice or hands-on experience, maybe. I mean, you might be able to guess what these mean, but there could be important words after it that just get cut off. Even when you don't have that, like in root cause, we still have a lot of different root causes, and we're trying to apply them. If I'd say yellow, I have to go back and look at what yellow is, assuming that there's only one yellow, as opposed to contributing causes in the top right, where there's a yellow and there's like a mustard yellow. And now if somebody says, well, what's that yellow? Oh, well, which one? We have scroll bars, incidents by facility, incident trends and their status. For incident trends and their status, this is particularly egregious because you'll notice that it's chronological order and it starts with the oldest date. When we look at a dashboard, we tend to care about the newest data. So every time I want to look at this, I'm going to have to scroll all the way to the right. Not only are you making me scroll, but you're making me scroll every time. This is not very good. At least if they did descending order. At least if you had to scroll, you would be scrolling back into history, so you don't always have to scroll. But here you do. There's reuse of color. Blue, 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 blue. And you look at the different blues in the pie charts, and you think, okay, well, they must mean about the same thing. So like blue is a lot of contributing causes, and it's a really big number of root causes. So it must be responsible for like the third most incidents by category. But then you look, wait, these are three totally different things. They just had the same colors because blue happens to be one of the colors. This is where I want to reuse colors when they mean the same thing, because that's what humans do. We see that color and assume it means the same thing. And now you're hoping that the person actually reads the chart and finds out that they're actually totally different. That doesn't always happen, by the way. There's some unnecessary chrome on this. I think you could save some pixels by eliminating these bars. We have things: export to Excel, copy, do something else, minimize, maximize. What I'd like to see, and I think Power BI does a pretty good job of this, is those bars can be helpful. If I want that, I'll use my mouse, I'll mouse over it, and then I'll get to see that information. Otherwise, if it's just a visual I want to show on a TV or I want to show it on a phone, I don't want that chrome. It's too easy for me to accidentally hit something. I could see hitting copy instead of Excel, or hitting Excel instead of copy by accident if I'm trying to touch it with my finger. It happens. So hide that stuff if you don't need it. Wrapping up, keep some tips in mind as you create your dashboards. Use the appropriate visuals. Color is something that you use as a signal. Use it consistently. Don't have different things be the same color on the same dashboard just because I need 18 colors. If you need 18 colors, you probably have too many colors. Avoid chart junk. Avoid that unnecessary chrome. That stuff just wastes space that you could be using for better visuals. Try to take things out of legends. Use visuals that don't need legends as much, or where you can keep the number of categories very small. You don't want to scroll. Make this thing glanceable, and scrolling kills glanceability. White space is your friend. That negative space is better than having strong borders. One thing I didn't even point out on here, I kind of did with Chrome, but the borders aren't really important. I could take those borders out and you could still tell that they're different visuals. So we don't need them. Finally, make sure that your dashboard is color vision deficiency friendly. Make sure that you're using an appropriate palette. Be sure that you're not using colors that are really difficult to tell apart when you're printing them out grayscale. Do all of these things and you'll have a much better dashboard. If you'd like to learn more, if you'd like to grab the slides or get links to additional resources, go to csmore.info/on/dashboards. And if you have any questions at all about this, please feel free to reach out to me, leave a comment below, or hit me up via email. So I have my email address, I have my Twitter handle, and with that, I want to say thanks for paying attention, and good luck building those great dashboards.